This is the Algebra 2 11.2 video notes. First, let's learn what an arithmetic sequence is. So the formula for an arithmetic sequence is this. A sub n equals A sub 1 plus, in parentheses, n minus 1 times d. And so when it's A sub 1, that represents the first term. And d represents the common difference. The number of terms that you're on. So first it wants us to tell whether each sequence is arithmetic. So what you do is you look for the pattern. So from -9 to -2, it's adding by 7. From -2 to 5, it adds 7. 5 to 12, it adds 7. And 12 to 9, it adds 7. All right. It is arithmetic because the common difference is 7. And so if they're adding or subtracting by the same amount every time, then it is arithmetic. So look for the pattern on B. From 23 to 15, it is subtracting by 8. 15 to 9, it's subtracting by 6. So right there, we can quit and we can say no, and there is no common difference. All right, let's look at example 2. It wants us to write a rule for the nth term of each sequence and then find term 15. So what we do is first we establish the first term. The first term in the sequence is 3. And now we identify the common difference, which is the pattern of change. So how it's changing every time is it's adding by 5. And so that's the common difference. So we use the formula A sub n equals, okay, it says A1, that's 3, plus, and then in parentheses, n minus 1 times the common difference, which is 5. You go ahead and you simplify. You distribute the 5 into this parentheses. So you have 5n minus 5, still with the 3 at the beginning. And then you simplify, and so you end up with 5n minus 2. So that is your arithmetic sequence. And if you want to find A15, that means the 15th term, you plug 15 in for n, and you can use a calculator, and you find out the 15th term is 73. Okay, let's do B. On B, the first term is 55, and you identify the common difference. This is going down by 8 every time, and so the common difference is -8. So we use our formula, A sub n equals first term plus, in parentheses, n minus 1 times d is -8. We distribute the -8, so we have 55 minus 8n plus 8, and then we simplify, so that gets us minus 8n, and then 55 plus 8 is plus 63. This is our arithmetic sequence. And if we want A15, that's the 15th term, we plug in 15 for n, and we find out that it is -57. Okay, on example 3, it gives you A19 equals -45. So that means the 19th term is -45. So what we can do is we can plug in what we know. So we know -45 is the 19th term. All right, we don't know the first term. Plus, we know when we're finding -45, the n is 19 because it's the 19th term. And then they also told us that d was -3. So I can use my sequence to find out what the first term is. So 19 minus 1 is 18, times -3 is -54. And I can simply add the 54 over, and I find out that 9 is my first term. So now if I go back through the process I had previously done, I can have A sub n equals 9 is the first term, n minus 1, the common difference is -3. So we distribute and simplify, and so my sequence is -3n plus 12. That's my arithmetic sequence. Now, it wants the first 6 terms graphed. So the first term is 9. The second term, you can plug in 2 and you get 6. The third term, if you plug in 3, you're going to get 3. The fourth term, you get 0. Fifth term is -3. And the sixth term is -6. Now, looking at these values, I'm going to go ahead and draw on my graph and just put the x-axis in the middle. And so I'm going to go by ones right here. And then honestly, I'm just going to go ahead and go by threes. So 3, 6, 9, and then I need to go all the way down to -6. All right, so 1 was at 9, 2 was at 6, 3 at 3, 4 at 0, 5 at -3, 6 at -6. And you don't connect them. And you can see they fall in a line, which makes sense because if arithmetic sequences have a common difference, that's like a slope. And so that means that they are linear. So they do make sense if they fall in a line. All right, on this arithmetic sequence, if it tells you it is an arithmetic sequence, then right there, like we just said, you know that is linear. And so when we have this fact right here, this is telling us the 7th term is 17, and this is saying the 26th term is 93. So you can kind of think about it as points, that when you plug in 26, you get 93. When you plug in 7, you get 17. So to find your common difference, let's find the slope, because really at its core, that's what the common difference is. So I get 4. Now to write a rule, which is just a sequence, we're going to go in and we have our first term, we don't know, and we don't know n, but we know our common difference is 4. So now use one of those 2 points. It doesn't matter if you use 717 or 2693. So I'm just going to use 717. And let me see if I can plug this in. So if I do that, 17 goes here. And then instead of n -1, I'm going to do 7 minus 1. This is n, and this is a sub n. So I could have done it with the 26 and the 93, and it should come out the same either way. So I end up with 7 minus 1 is 6. 6 times 4 is 24. And so I subtract the 24, and I get -7 is the first term. So to write our sequence, we now know our first term. We know our common difference. And so let's distribute the 4. Simplify, I get 4n minus 11, and that is my sequence. So when they give me 2 terms, not including the first one, I can use those 2 terms to find the slope, which is basically the common difference. And then I can use one of those 2 terms with the common difference to find the first term. And anytime you have the first term and the common difference, you're going to go through this process to write your sequence. And that can be a rule, is what they call it. And always simplify, and you put n in front. It's kind of like y equals mx plus b form. Okay, let's change this to say sum of a finite arithmetic series. All right. So we know that it's finite. Finite means it ends. It does not go on forever. And so if we know that it's finite, we can use this formula to find the sum of the arithmetic finite series. So let's write it down. All right, so we know A1 is our first term. AN is our nth term. N is how many terms there are. So when we see this is a summation notation. You see the I equals 1. It can be written out to the side of the bottom of this sigma, or it can be written underneath. And then the 20 can be written along the top, or it can be written out just to the right. So those are the same things. Like if I just rewrote it to show you a different way. And then it shows 3i plus 7. So this top number is your n. All right, and so we have our n. We need our first term. Our first term is when you plug in 1 for I. So you're going to do 3 times 1 plus 7. So 3 times 1 plus 7, you get 10. Your first term is 10. All right, now let's find our 20th term. I know I want the 20th term because that's n. This means I'm going to go from term 1 to term 20, and I'm going to add them all up. That's what it means. So term 20, I plug in 3 times 20 plus 7. That gets me 67. And then, of course, my n is 20. So to find the sum of the first 20 numbers in this arithmetic sequence, I could list them all out. So I could sit here and find the first number, second, third, fourth, all the way to 20 and add them up. But the shortcut is by using this formula. So it says to find the first 20 term sums equals n is 20. That means we're adding 20 terms. And then in the parentheses, A1 is 10. Plus AN, this means the 20th term, the last term in my sequence. The 20th term was 67 divided by 2. So I'm going to have 20 times 77 divided by 2, which equals 770. So what that means is if you found the first 20 terms in this arithmetic sequence and added them all up, it would be a total of 770. Okay. This is kind of where we see an application problem. So you're making a house of cards similar to the one shown. Write a rule for the number of cards in the nth row when the top row is 1. Okay, so look how they circle the top row. It is made up of 3 cards. So row 1 is 3 cards. So row 2 is made up of the 2 triangles like this. So row 2 is 6 cards. And then row 3 is made up of like 3 card triangles. And so that involves 9 cards. I just looked at the picture to count these up. So I can see that my first term is 3. In my common difference, it's going up by 3s every time. And so my common difference is also 3. So to write my rule, I'm going to plug in A1 plus n minus 1 in parentheses times our common difference of D. I distribute and then simplify. And so I end up with 3n, and that's my rule. Now, it wants to know how many cards do you need to make a house of cards with 12 rows. So we want to find the sum. If it wants how many cards, it's the sum of all 12 rows. So what we do is we need to know n, we've got that. We need to know the first term. Okay, that's 3. We need to know the 12th term. So if we plug in 12, 3 times 12 is 36, meaning row 12 will have 36 cards. So since we want to sum, and it is a finite sequence because it does have an end, you do n times, and then in parentheses you have A1, which is 3, plus 36, which is the last row, the 12th row, divided by 2. And you're welcome to use a calculator for that, and you get 234 cards. So if you built a house of cards that had 12 rows, you would need 234 cards to do so.